So I guess I'm only on example 5 of this note section. And how many? There's 9. Hopefully they start getting shorter, because the first 3 were super long. 4 was alright, because there was one solution. Okay. Let's see if I remember this. Solve 9 sine 2x equals -5 cos 2x on -10 0. So let's see. Probably gonna put cos over sine, so we're gonna divide. I'm gonna rewrite this. I'll just divide the whole term over 2x 9 sine 2x over -5 cos 2x. Zero. I wonder if we can rewrite this as 9 over, or -9/5 times sine 2x over cos 2x, and then like divide it over. Gives me 0 though. Then I would just have tan 2x equals 0. I don't think this is right. I probably did something wrong. Let's check out the first part of this. Okay, yeah, I definitely did something wrong. Or wait, it's example 6. Let's see. Okay, at first glance, this problem seems to be at odds with the sentence preceding the example. However, it really isn't. First, when we have more than one trig function in an equation, we need a way to get equations that only involve one trig function. There are many ways of doing this that depend on the type of equation we're starting with. In this case, we can simply divide both sides by a cosine, and we'll get a single tangent in the equation. You can now see that this really is an equation that doesn't involve sine or cosine. So let's see. Okay, they didn't really show how they got there, but I'm guessing. Let's restart. So, okay, this can be rewritten as cos 2x times -5, and then 9 times sine 2x. So, just divide out the cos 2x. Put this over cos 2x. I want to get the 9 and the 5 by itself, though. You know, I think I still can, maybe? 9 times sine 2x over cos 2x equals -5, and then just like divide by 9. That's probably how they did it. So sine 2x over cos 2x equals -5/9. Turn that into tan 2x equals -5/9. Okay, I think. Oh wait, you can move the. Hold on. No. Okay, they don't move it. They just say. Let's use inverse. So tan, the inverse of -5/9 equals 2x. Okay, so from here it's the same thing pretty much as yesterday. Gotta pull up the calculator. There we go. Okay. So inverse tan -5/9. So we got -0.5071 equals 2x, divide by 2 on both sides. So -0.5071 divided by 2. X, you know what, I don't want to divide by 2 yet actually. Because what this gave is the radian for the unit circle. This is negative, so let's see, this would be in quadrant 1 if it was positive, I'm pretty sure, because pi/2 is 1.5, so this would be normally be in quadrant 1 about like here, so it's gonna be here instead. Okay. To find this, take 2 pi minus 0.5071, because we're taking the whole circle minus this part, and that's going to get the radian version of the reference angle. So, wait, am I in radian? Yeah. 2 pi minus 0.5071. 5.7761. Okay. So that's for this right here, 5.7761. And then, okay, so this is a negative tan. So tan is also negative. No, it's not negative there. It would be negative here, because all students take calculus. Yeah, okay. Just these two quadrants, 2 and 4. So to find this one, we just take pi minus 0.5071. Pi minus 0.5071. And it did that thing again, nice. Pi minus 0.5071. 2.5071. So we got 2.6345 plus 2 pi n plus 2 pi n. I'm going to rewrite these down here and say 2x equals 5.7761 plus 2 pi n, and then 2x equals 2.6345 plus 2 pi n, divide by 2. Yeah, x equals 5.7761 divided by 2, 2.8881 plus pi n, divided by 2 on all terms at the bottom. Got x equals 2.6345 divided by 2, not 3. We got 1.3173. 1.3173 plus pi n. So before I go looking for all the solutions, I'm going to make sure that I wrote these down right. Or did I stop reading? So let's get started on this example. Okay, you did that. Same thing I did. Now the unit circle doesn't involve tangents, however we can use it to illustrate the second angle in the range 0 to pi. The angles that we're looking for here are those whose quotient of sine over cosine is the same. The second angle, where we will get the same value of tangent, will be exactly opposite of the given point. For this angle, the values of sine and cosine are the same except that they will have opposite signs. In the quotient, however, the difference in signs will cancel out and we'll get the same value of tangent. So the second angle will always be the first angle plus pi. Before getting the second angle, let's also note that, like in the previous example, we'll use the 2 pi minus 0.5071 equals 5.7761 for the first angle. Again, this is only because of a concern about losing track of the minus sign in our calculator answer. We could just as easily do the work with the original angle our calculator gave us. Now this is where it seems like we're just randomly making changes and doing things for no reason, really. The second angle that we're going to use is pi plus negative 0.5071 pi minus 0.5071 equals 2.6345. I think that's what I got. Yeah. The fact that we use the calculator answer here seems to contradict the fact that we used a different angle for the first above. The reason for doing this here is to give a second angle that is in the range 0 to pi. Had we used 5.7761 to find the second angle? Yeah, we get that. This is a perfectly acceptable answer, however it is larger than 2 pi. And the general rule of thumb is to keep the initial angles as small as possible. Here are all the solutions to the equation. So x equals 2.8881 plus pi n. X equals 1.3173 plus pi n. Okay. So I'm on the right track. X equals 2.881 plus pi 1. Oh yeah, let's circle these first of all. So I'm not going to rewrite this. Let's just find the answer. 2.8881 plus pi 6.0297. What's the interval? 0. Oh. 0. Okay, never mind. So neither of these are answers. None of these. But I don't want to erase my work for this actually. Or wait, no, I can because these were answers to begin with. So I'll take this times a -1. 2.8881 minus pi equals 2.8881 minus pi -0.2535. That is greater than -10, so it works. 2.8881 plus pi -2. 2.8881 plus minus 2 pi. That equals 2.8881 minus 2 pi. -3.3951. -3.3951. And that is greater than -10, so it works. 2.8881 plus pi -3. 2.8881 minus 3 pi equals 2.8881 minus 3 pi. That is -6.5367, which is greater than -10, so it works. 2.8881 minus 2, minus plus pi -4. 2.8881 minus 4 pi equals 2.8881 minus 4 pi. We got a -9.6783, which is greater than -10, so it's a solution. 2.8881 plus pi -5. 2.8881 minus 5 pi equals 2.8881 minus 5 pi equals -12.8199. So x does not equal that because it is less than -10. So it's not a solution. What was the other one? X equals 1.3173 plus pi n. 1.3173 plus pi -1 of 1. I'm just gonna get the answer. 1.3173 plus pi, no, negative pi negative 1.824 3, which is greater than negative 10, so it's a solution. 1.3173 plus pi negative 2. 1.3173 minus 2 pi equals 1.3173 minus 2 pi. Negative 4.9659, which is greater than negative 10, so it's a solution. 1.3173 plus pi negative 3. 1.3173 minus 3 pi equals 1.3173 minus 3 pi, negative 8.1075, which is greater than negative 10, so it's a solution. 1.3173 plus pi, negative 4. 1.3173 minus 4 pi equals 1.3173 minus 4 pi, negative 11.2491, which is less than negative 10, so it's not a solution. Okay, so I got all of them, hopefully. Seven solutions to this equation are then, see, negative 8.1075, negative 4.9659, negative 1.8243, negative 9.6783, negative 6.5367, negative 3.3951, negative 0.235, and should be it. So I got 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. Alright. Note as well that we didn't need to do the n equals 0 computation, since we could see from the given interval that we only wanted negative answers, and these would clearly give positive answers. Before moving on, we need to address one issue about the previous example. The solution method used there is not the standard solution method, because the second angle is just pi plus the first, and if we added pi onto the second angle, we'd be back at the line representing the first angle. The more standard solution is just to add pi n onto the first angle. If using the calculator, this would give, okay, if using the positive angle corresponding to the calculator answer, this would give, okay, then dividing by 2 either of the following sets of solutions. Okay, either of these sets of solutions is identical to the set of solutions we get in the example. We'll leave it to you to plug in some n's and verify that. No thanks. So why did we not use the method in the previous example? Simple. The method in the previous example more closely mirrors the solution method for cosine and sine, i.e. they both generally give two sets of angles, and so for students that aren't comfortable with solving trig equations, this gives a consistent solving method. Many calculators today can only do inverse sine, inverse cosine, and inverse tangent, so let's see an example that uses one of the other trig functions. I swear I did this. Or I read that. You know, I might have read this by accident, but I didn't do example 5, because I don't remember doing example 5. Let's see. Example 4. Yeah, I must have read that by accident yesterday. Make a new page then. Okay, so example 6. Solve 7 secant 3t equals -10. So divide by 7 on both sides. Secant 3t equals -10 over 7. Let's see. 1 over inverse cosine equals of -10 over 7 equals 3t. So 1 over inverse, dang it, 1 over inverse cosine of -10 over 7. There. Are you kidding me? Bruh. I cannot write this. Use this calculator. Like, I don't know what I'm supposed to do to type this in. What do they want from me? Like, I gotta look this up because I have no idea how to type this in the calculator. We'll start this one in exactly the same way as we've done all the others. Okay, I think that's what I did. Yep. Now we reach the problem. As noted above, many calculators can't handle inverse secant, so we're going to need a different solution method for this one. To find the solution here, we'll simply recall the definition of secant in terms of cosine and convert this into an equation involving cosine instead, and we already know how to solve these kinds of trig equations. Huh? So then it just flips. It just flips, are you kidding? Okay. 1 over cos 3t equals -10 over 7. So if I do this, this just flips. Really? Okay. So find the inverse of -7 over 10 equals 3t. So inverse cos -7 over 10. So 2.3462 equals 3t. Divide by 3. T equals or I'll do the thing first. 2.3462 plus 2 pi n divided by 3. Or wait, I gotta find the other one too. So this is past the first quadrant for sure. Where's the second one? Okay, it's definitely the second one. So like maybe here. And what is this? Cosine. It's a negative, so okay, so it has to be here. So this is 2.3462 right here. To get the other one, I do pi plus, probably be 2 pi minus 3.462. Let me check. So we got this. Okay. Subtract 2 pi. That'd just give this. Right. So maybe not. But it pi minus 2.3462 gives 0.7954 for this thing. So I add that together, or I just say pi. So pi plus 0.7954. So from here to here, 3.936 or 370. 3.9370. Okay. So 2.3462 plus 2 pi n equals 3t. 3t equals 3.9370 plus 2 pi n divided by 3. T equals 2.3462 divided by 3. 0.7821 plus 2 pi n over 3. So I'll just circle this whole thing, square it, divide by 3 on the bottom. T equals 3.9370 divided by 3, 1.3123 plus 2 pi n over 3. I think that's it. No, really? Or wait, no, I was, okay, yeah, I'm right. 0.7821 plus 2 pi n over 3. 1.3123 plus 2 pi n over 3. There's no interval. Okay. For the remainder of the examples in the section, we're not going to be finding solutions in an interval to save some space. If you followed the work from the first few examples in which we were given intervals, you should be able to do any of the remaining examples if given an interval. Also, we will no longer be including sketches of unit circles in the remaining solutions. We're going to assume that you can use the above sketches as guides for sketching unit circles to verify the claims in the following examples. The next 3 examples don't require a calculator but are important enough or cause enough problems for students to include in this section in case you run across them and haven't seen them anywhere else. Okay. Example 7. Cos 4 theta equals -1. So, inverse cos -1 equals 4 theta. Okay, so this is just pi. So pi equals 4 theta. Because I guess on the unit circle, since cos is x, -1 is on the left side. So yeah, that's pi. Divide by 4. Theta equals pi over 4. I think that's all we have to write. No interval, right? Yeah. There really isn't much to do in this problem. It is, however, different from all the others done to this point. All the others to this point have had 2 angles in the interval 0, 2 pi. There were solutions to the equation. This only has 1. Oh wait, plus 2 pi n, I got it right. Yeah, this only has 1 though. If you aren't sure, you believe this sketchy unit circle, and you'll see that in fact that there is only 1 angle for which cosine is -1. Here's a solution to the equation. So theta equals pi over 4 plus, I forgot to divide by 4 up here. What would it be? Pi n over 2? Yeah. Solve sine of, is that omega? Look this up. Alpha, okay. So example 8. We got alpha. No, it's terrible. Something like that. Right, I know. There. Over 7 equals 0. So, what do I want to do? Oh, it's sine. So sine, inverse sine of 0 equals alpha over 7. What's sine of 0? There's 2 different places. It could be, let's see what the calculator gives. Okay, so the first one's 0, I think. Won't the other one be pi? So 0 equals alpha over 7. Alpha equals 0 plus 2 pi n. So that's one of them. Or it could be pi equals alpha over 7. 7 pi equals alpha. Alpha equals 7 pi plus 2 pi n, maybe. Let's see. Wait, 14. And they get 14 pi n. Oh, I forgot to, man, I always forget. So this is 2 pi n over 7. And this is 14 pi n. Or no, this is also 14 pi n. Yeah, okay. Because you're still multiplying by 7. The next example has an important point that needs to be understood when solving some trig equations. Okay. So this is example 9. Sine 3t equals 2. So inverse sine of 2. Oh, you can't do this. Equals 3t. No solution. Because you can't have a sine greater than 1. What do you get if you plug that in? Yeah, you can't. Okay. This example is designed to remind you of certain properties about sine and cosine. Recall that sine has to be between -1 and 1, and cosine has to be between -1 and 1. Therefore, since sine will never be greater than 1, it definitely can't be 2, so there are no solutions to this equation. It is important to remember that not all trig equations will have solutions. You know what, I think when I thought I read this one part up here, it was in the last section, kind of, maybe. Because this document is also being prepared for viewing on the web, we're going to split the section in two in order to keep the page size, and hence the load time in a browser to a minimum. In the next section, you're going to take a look at some of the slightly more complicated equations, although as you'll see, they aren't as complicated as they may at first seem. Sick. So 1.6. Paul's online math notes, section 1.6, solving trig equations. This looks terrible, actually. Equations with calc part 2. Can't really read that, but it's fine. So because this document is also being prepared for viewing on the web, it's split into 2 parts. Also, as for the last few examples in the previous part of this section, we are not going to be looking for solutions in an interval in order to save space. The important part of these examples is to find the solutions to the equation. Alright, I'm glad we're not doing that interval stuff anymore. It took up so much time. If we'd been given an interval, it would be easy enough to find the solutions that actually fall in the interval. And all the examples in the previous section, all the arguments, the 3t, alpha over 7, etc., are fairly simple. Let's take a look at an example that has a slightly more complicated looking argument. So, example 1. 5 cos 2x minus 1 equals -3. So first, going to divide the 5 on both sides. Cos 2x minus 1 equals -3/5. Cos -1 of -3 over 5 equals 2x minus 1. I gotta find that. So cos, inverse cos, -3/5. So 2.2143. 2.2143 equals 2x minus 1. So we're going to add 1 on both sides. 3.2143 3.2143 equals 2x. Divide by 2 on both sides. X equals 3.2143 divided by 2. We got 1.607 2. So, wait, we don't want to divide by 2 yet, actually. So 2x equals 3.2143 plus 2 pi n. So this is a cos and it's negative. Draw out the unit circle. So, is this in the second or third quadrant? This is going to be barely in the third quadrant. Okay. So about right here. And then this is negative cosine. So also negative here. So just pi minus 3 point, or no. Or no, yeah, that is what I want actually. 3.2143 equals pi minus 3.2143 negative 0.072 7. That's not right. Yeah, okay, I did it wrong. So that would be like taking pi minus this entire thing. So I'd want to do pi plus that, or no, I want to take this whole thing, so 3.2 whatever minus pi minus this. No, wait. Man, I can't think today. Alright. Let's see. Okay, that'd be like step 1. So we'll take 3.2143 minus pi (3.2143) minus pi 0.0727. So like we took this minus this, so now we have like this angle here, which is also the same as this. So if we do pi minus 0.0727, I'm sure there's a one-step way to do this, but this is how the only way I can think about it. So we got pi minus 0.0727, 3.0689. Let's see. Okay, so first we took this, subtracted this, then I got the triangle here, then I took the triangle here, I took pi minus that triangle, so now I have this angle, which is 3.0689, so that's what I wanted. So 2x equals 3.2143 plus 2 pi n, and 2x equals 3.0689 plus 2 pi n. Divide by 2. We get x equals 3.2143 divided by 2, 1.6072 plus pi n. Divide by 2 on the bottom. X equals 3.0689 divided by 2. We got 1.5345 plus pi n. There's no interval, so I think this is about it. Note that the argument here is not really all that complicated, but the addition of the -1 often seems to confuse people, so we need a quick example with this kind of argument. The solution process is identical to all the problems we've done to this point, so we won't be putting in much explanation. Here's a solution. So they got 2.2143 for the inverse. Set that equal to 2x minus 1. This angle is in the second quadrant, and so we can use... Wait, is this in this... Wait, what? Or, yeah, that one was. But then you gotta divide by 2. Or wait. No, then you gotta add 1 there. That's, yeah, that's what I meant. So we can use either whatever or that. Oh, wait, I did it the wrong way, I think. You're supposed to add the 1 after you find the angles and all that. Dang it, man. I'll have to redo this. No, I'll just delete this whole thing. Man, that's like most of my work too. Unfortunate. So yeah, this is in the second quadrant. Cos is also negative down here. Same thing applies. So this is 2.2143. So if we take pi plus 2.2143, should get the other angle. Pi plus 2.2143, 5.3559. And that is from here to here. 5.3559. Or you know I did this wrong. No, that's not right. It would be pi minus 2.2143 first. That's 0.9273, which is this triangle here. Pi plus 0.9273 equals, this is what we want, 0.9273, 4.0689. So this is 4.0689. So now that we have these, 2.2143 equals 2x minus 1, and 4.0689 equals 2x minus 1. So add 1 over 3.2143 equals 2x, divide by 2, x equals, I'll give the answer, I'll go down here before I use the calculator, plus 1, 5.0689 equals 2x, divided by 2, x equals, okay. 3.2143 divided by 2, 1.6072 plus 2 pi n. So that's the first one. And the second one is 5.0689 divided by 2, 2.5345 plus 2 pi n. I messed up again. Man, I keep forgetting to divide that 2 pi n. Do I gotta add 1 to it also? No, I don't think I do. I think that's, yeah, that's only for division and multiplication. You gotta do it every term. But yeah, I do gotta divide by 2, so it'd just be pi n. What is that smudge? It's not the eraser, that's fine. Plus pi n. Alright, let's check it. $1.6072 plus pi n, 2.5345 plus pi n. Okay. Example 2. So in this example we saw an argument that was a little different from those seen previously, but not all that different when it comes to working the problem, so don't get too excited about it. We now need to move into a different type of trig equation. All of the trig equations solved to this point, the previous example as well as the previous section, were in some way more or less the standard trig equation that is usually solved in a trig class. Okay. There are some other types of equations involving trig equations, however, that we need to take a quick look at. The remaining examples show some of these different kinds of trig equations. Okay. 4 more examples in this section. I'll probably finish these up, call it a day. I don't want to go for too long today. Then maybe in 2 more days I'll be done with the review. Unless I go crazy tomorrow. We'll see. So 2 cos 6y plus 11 cos 6y sine 3y equals 0. Okay. Anything else? No, that's all. So everything's already sine and cos. Can't combine the coses because there's a sine attached to the one cos. And I can't divide by sine because I'd have to divide. Wait. No, because I'd just make a bigger mess. First thing I'm seeing is to subtract this over, so 2 cos 6y equals negative 11 cos 6y sine 3y. Okay, if I divide a sine over, I'd get cotangent. But no, I can't because there's a different value. That's annoying. Divide the cos maybe? What does this really do though? Alright, I'm stuck. Need some help. So this definitely doesn't look like any of the equations we've solved to this point, and initially the process is different as well. First, notice that there's a cos 6y in each term. So let's factor that out. Wait, is there? Oh wait, how did I not? I was looking for factors too. I'm like, you can't factor a sine out. I didn't even think about the cos. Okay, so cos 6y we're left with 2 plus 11 sine 3y. So what do I want to do with this? I could literally just like 2 plus 11 sine 3y. 2 plus 11 sine 3y. Cos 6y equals 0, right? Cos, inverse cos of 0 equals 6y. When cos is at 0, it can be pi, it can be 0, wait. Okay, never mind. 1.5708 equals 6y. Divide by 6 on both sides. Did that thing again, nice. 1.5708 divided by 6. Y equals, I don't want to divide by 6 yet, actually. Pull up my unit circle. So this is exactly pi over 2. Like, exactly. Which, oh, okay. Because if the cos x is 0, it can either be pi over 2 or 3 pi over 2. Got it. So you could just say pi over 2 equals 6y. Hold up. Pi over 2 equals 6y. 3 pi over 2 equals 6y. Divide by 6 for both. Pi over 12 equals y. Oh wait, rewrite that. Y equals pi over 12 plus pi over 3, pi n over 3. Is that be it? Wait, divided by 6. Yeah, I think it is. And then divide by 6 over here. 3 pi over 12 plus, same thing, pi n over 3. Is that it? Pi over 12 plus pi n over 3. Pi over 4, oh wait. Yeah, this can be simplified to pi over 4. Pi over 4 plus pi n over 3, or they wrote it in decimal form. I'm not going to do that. Let me read through this whole thing. We now have a product, 2 terms that is 0, and so we know that we must have this. Now at this point, we have 2 trig equations to solve, and each is identical to the type of equation we were solving earlier. Because of this, we won't put much detail into solving. So solving cos 6y gives, solving the other one gives. Remember that in these notes we tend to take positive angles, and so the first solution here is in fact that, where our calculator gave us this as the answer when using the inverse sine function. The solutions to this equation are then whatever this is, and yeah, I already checked them, we're good. This pi n over 3, right? Yep. So this next example also involves factoring trig equations, but a slightly different manner than the previous example. Okay, let's try it. So 4 sine squared t over 3 minus 3 sine t over 3 equals 1. So take a sine out. Of sine t over 3. That would leave 4 sine, just 4 sine t over 3 minus 3. Does this help? Wait, if I did sine t over 3 sine t over 3. 4 sine t over 3 minus 3 equals 1 over sine t over 3. So this could be rewritten as cosecant t over 3 equals 4 sine t over 3 minus 3. I don't like where this is going. I'm gonna look at the example. I feel like I made it a lot worse. For solving, oh, they're like factoring it. It is a quadratic, isn't it? Huh. Okay. And they're just treating the signs like x's. Okay, that's smart. I didn't even notice it was quadratic because of all the trig functions. 4x squared minus 3x squared minus 1 equals 0. 2x plus 1. 2x minus 1. 4x squared minus 2x plus 2x now. Be 4x minus 1x minus x plus 1. 4x squared plus 4x minus, why is this squared? Minus x minus 1, okay, that's it. So 4x minus 1 equals 0. X plus 1 equals 0. Is this when we put in the, put the signs back in? 4 sine t over 3 minus 1 equals 0. And then sine t over 3 plus 1 equals 0. Okay, these are a lot easier. 4 sine t over 3 equals 1. Divide by 4. Sine t over 3 equals a fourth. Over here we got sine t over 3 equals -1. So now I gotta solve both of these. So sine -1, or inverse -1 equals t over 3. So when sine is -1, there's only one solution to that, right? It would be 2 pi over 3 equals t over 3, I'm pretty sure. Let me pull out the unit circle just to make sure. Yeah, it's -1 in one spot, 3 pi over 2. Oh, I said 2 pi over 3, whoops. 3 pi over 2 equals t over 3. So multiply by 3. Nine pi over 2 equals t. So t equals I forgot to multiply by the 3 on the other one. I'll just do it in my head. 9 pi over 2 plus 6 pi n. So I did that right? I think that's the first one. Over here, this one's a little crazy because it's 0.25. I'll rewrite that. Sine t over 3 equals 0.25. Alright, I'm gonna find inverse. So inverse sine of 0.25 equals t over 3. 0.25 0.2527 equals t over 3. Multiply by 3. I'll do the multiply the other one by 3 in a second. 0.2527 times 3. T equals 0.7581 plus 6 pi n. And there's another one I gotta get. So I'll draw out the unit circle. The angle I got 0.2527. That's gonna be in the first quadrant. I'll just say here. And it's a positive, so it has to be in this one. So if I take pi minus 0.2527, then yeah, I should get this. So I'll write that down. Pi minus 0.2527 2.8889 equals t over 3 times 3 times 2.8889, and we get t equals 8.6667 plus 6 pi n. And there should be the 3, so let's check. Whoa, what'd they get? Okay, let me go through the whole thing. So before solving this equation, let's solve an apparently unrelated wait, what is this? Oh no, okay, that's good. So they got 4x plus 1 plus 1, x minus 1. This is an easy, or at least we hope it's easy, this point equation to solve. The obvious equation then is, why did we do this? Question. Well, if you compare the two equations, you'll see that the only difference is the one we just solved has an x everywhere, and the equation we want to solve has a sign. What this tells us is that we can work the two equations in exactly the same way. We will first factor the equation as follows. Now set each of the two factors equal to 0 and solve for the sign. Oh, okay, they kept get. If I would have just did one more step with my factors before plugging it in. I love deleting work. So 4x equals 1, x equals a fourth, and x equals -1. Okay. So sine t over 3 equals a fourth. Sine t over 3 equals -1. -1 can still only be one thing, so we got pi 3 pi over 2 equals t over 3. I skipped a step. But it's fine. Plus 2 pi. So multiply by 3. 6 pi plus 9 pi over 2 equals t. Really? They're getting decimal. Oh crap. How did they get 3 pi over 2? That's before you like multiply by 3. Wait a minute. What happens to the t over 3? It's still a thing. Wait, they got negative a fourth. (4x squared plus 4x). I factored. Dang it. I factored wrong. Are you kidding? I even wrote it down. Okay, so 4x squared minus 4x plus x minus 1. So 4x plus 1, x minus 1. So x equals 1. 4x equals -1. X equals -4. Alright, at least not too much work. Has to be erased this time. So sine t over 3 equals 1. Inverse sine of 1 equals t over 3. So when does sine equal 1? It's only in one spot, which is pi over 2, right? That's how they're getting 3 pi over 2. 3 pi over 2. So t equals 3 pi over 2 plus 6 pi n. I think that was one of the 3 pi over 2 plus 6 pi n. Okay. Now I gotta get the decimals for this. So we got sine t over 3 equals -1/4. Sine, inverse sine of -1/4 equals t over 3. So inverse sine (1/4) -0.2527 equals t over 3. Multiply by 3. Right. -0.2527 times 3. T equals -0.7 581 plus 6 pi n. So if we draw this out in the unit circle, it's a negative sign this time. And this will be somewhere in the fourth quadrant. Here or something, I don't know. And the other one will have to be in the third quadrant. So to find this, I'm going to find the positive version of this. So 2 pi minus 0.2527 6.030. Okay, that's this entire thing up to here. 6.0305. You know what? I didn't actually need that, but I think that's what they had for. Yeah, that's what they had for their answer up here. So actually, I'll rewrite this down here. All I need to do to find the other one is pi plus be pi Okay, well first I gotta do 2 pi minus 6.0305 so 0.2527. So that's what this like triangle thing is, that angle. So then I add pi plus 0.2527, and that equals 0.2527, 3.3943. So from here to here, 3.3943. Okay, so first I'm going to rewrite t equals 6 t over 3 equals 6.0305. And then t over 3 equals 0.2527, wait, no, 3.3943 plus 2 pi n plus 2 pi n, multiply by 3 for every term. And I get, for the top one, t equals 6.0305 times 3, 18.0915 plus 6 pi n. T equals 3.3943 times 3, 10.1829 plus 6 pi n and I think those are all my answers. Yeah, the other one's all the way up there. Check that one already. So 18.0915 plus 6 pi n, 10.1829 plus 6 pi n, and I already checked it, but t equals 3 pi over 2 plus 6 pi n. So, and that is example 3 done. So we now have two trig equations that can easily, hopefully, solve it. You can easily solve at this point. We'll leave the details to you to verify that the solutions to each of these, and hence the solutions to the original equation, are all this. I did that. The first two solutions are from the first equation, and the third solution is from the second equation. Let's work on more trig equations that involve solving a quadratic equation. However, this time, unlike the previous example, this one won't factor, and so you'll need to use the quadratic formula. But why would you do that to me, man? I'm trying to call it a day soon. It's already been an hour and a half. 8 cos squared 1 minus x plus 13 cos 1 minus x minus 5 equals 0. Okay, so I'm glad he at least told me that when in fact I need to use quadratic formula. So 8 x squared plus 13x minus 5 equals 0. So a equals 8, b equals 13, c equals negative 5. Okay, so quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. X equals negative 13 plus or minus 13 squared minus 4, 8, negative 5 all over 2 times 8. So I'll plug this into the calculator. Okay, negative 13. Wait, what do you do with the plus or minus again? No, I gotta find both. Plus square root of 13 squared, oh crap, minus 4 times 8 times negative 5, parentheses again because that's the top, divided by 16. So x equals 10. That was for adding. And negative 13 minus square root 13 squared minus 4 times 8 times negative 5. I forgot to put that whole thing in parentheses. Negative 13 minus, not plus, minus square root of 13 squared minus 4 times 8 times -5 parentheses divided by 16. Okay, x equals 8.375. Or it'd be or. Whatever. Could be both. Maybe it's both. I don't know. So, okay, let me make sure that I typed it in right, first of all, because I don't want to keep going without doing that. Now, as mentioned prior to starting the example, this quadratic does not factor. However, that doesn't mean all is lost. Okay, you can solve the following equation with the quadratic formula. You do remember this and how to use it, right? I guess not, because I got the wrong answers. So what did I type in wrong? Had 8x squared plus 13x minus 5 equals 0. A equals 8, B equals 13, C equals -5. So what would be inside the root? He got 329. 13 squared. 169. Okay, so 169 minus 4 times 8, so 32 times -5. 32 times -5. -160. Distribute the negative. 169 plus 160. 169 plus 160. 329? Yeah. And 16 at the bottom, yep. So I guess I typed it in wrong. -13 plus or minus square root of 329 over 16. Maybe it was that exponent. Might have been that exponent. So let's try it again. -13 plus square root of 329 divided by 16. Okay, we're getting there. X equals 0.3211. That's it. Okay. And then x equals okay, -13 minus square root of 329. Oh, I messed up. Would it still work? It might still work. Let's try. -14. No, okay. Yeah, I gotta use parentheses. -13 minus square root of 329 end parentheses divided by 16. -1.9461. -1.9461. And then 0.3211. Okay. Quadratic formula was the toughest part for some reason. Well, I don't know that yet, but Seems like it. So the original cos 1 minus x equals 0.3211, and cos 1 minus x equals negative 1.9461. So I want to find the inverse cos of 0.3211 equals 1 minus x, and I should get 1 minus x equals 0.3211, 1.2439. And I'm going to keep it like that for now, before I find the other solution. Not just this one, but like the whole other. Inverse cos of negative 1.9461 equals 1 minus x. 1 minus x equals inverse cos of negative 1.9461. Dang it, man. Inverse cos negative 1. Wait. This isn't even possible. That's not possible to do. So there's no solution for that one then. There can't be. No solution for that. Move this down. Or I don't have to, but let's see. I'm gonna find 1.2439, that's definitely in the first quadrant. And what is this? This is cos, and it's positive. So all students take calculus. Okay, so positive down here. Let's see. Zero 0.3211. So this would be 0.3211. What do I want to do to find the other angle? Alright, well that would be trying to find this, which is also 0.3211. So if I just took 2 pi minus 0.3211, I should get the answer. 2 pi minus 0.3211. 5.9621. That's this whole thing. 5.9621. So I'll write down the 2 that I have now. 1 minus x equals 1.2439 plus 2 pi n, and 1 minus x equals 5.9621 plus 2 pi n. So I can add over or subtract the 1. Negative x equals 0.2439 plus 2 pi n, and negative x equals 4.9621 plus 2 pi n. Divide by negative 1. X equals 0.2439 negative 0.2439 minus 2 pi n x equals negative 4.9621 minus 2 pi n. Alright, we'll see what he does about these negatives, or if he just leaves it. For now, I'm not going to box him in, but why not? This is what I got, so. Anyway, so we use this quadratic formula, gets us two answers. So if we can use the quadratic formula on this, then we can also use it on the equation that we're asked to solve. Doing this gives us cos 1 minus x equals 0.3211. Oh, he turns it into a negative to start with. Or wait, what did he do? Wait. Okay, I mean, or no, that's just the other, answer, even though it's not an answer. Now recall example 9 from the previous section. In that example, we noted that negative 1, cos has to be between negative 1 and 1. And so the second equation will have no solutions. Therefore, the solution to the first equation will yield the only solutions to our original equation. Solving this gives the following set of solutions. Negative 0.2439 minus 2 pi n. Negative 4.9621 minus 2. Oh, wait, I did that wrong. 0.2439 minus 2 pi n. That's right. What could I have done wrong here? It would have had to be in when I subtracted. Okay, hold on. So this is 0.3211. To make it, it's cos. So for it to be positive, and it's positive, so for it to be positive, it has to be in this quadrant. So what I did was I took the entire circle, and I subtracted this triangle part. Did I type it in wrong, or no? No? Okay. This is a weird one. I don't understand, because it's definitely in the first quadrant to begin with. Would 5.0393, would that be in the fourth quadrant? No, that'd definitely be in the fourth quadrant. Like, how did I get this wrong? It's definitely 0.3211. Has to be in the fourth quadrant. Okay, so we had to have used 3.3211 in some way, right? It's a negative version of this. Or wait, I did that wrong. Negative 0.3211. Wait, how do you... Here, 0.32111 minus 2 pi. Yeah, you know, it sucks, but I think I'm just gonna have to be stuck on this, because there's no, like, way to really check. Dang it, man. And one of them was right, 0.2439. And this has to be 0.3211. And it is cos, and it's positive. And it's in the fourth quadrant. I don't know. Unfortunate, I guess. I'll just 0393. Yeah, I don't know. Note that we did get some negative numbers here, and that does not seem to violate the general form that we've been using in most of these examples. However, in the case, the negative are coming out about when we solve for x after computing the inverse cosine in our calculator. There's one more example in the section that we need to work that illustrates another way in which factoring can arise in solving trig equations. This equation is also the only one where the variable appears both inside and outside of the trig equation. Not all equations in this form can be easily solved, however, some can, so we want to do a quick example of one. Good. Quick example. Let's go. Example 5. 5x tan 8x equals 3x. Factor out an x. 5. Wait, this is one whole term right here. So 5 tan 8x equals x3 divided by x. 5 tan 8x equals 3 divide by 5 on both sides. Tan 8x equals 3 over 5. Inverse tan of 3 over 5 equals 8x. Three divided by 5. 0.5404 equals 8x divided by 8. Or wait, I don't want to do that. Let's see if I could stay on this page. Small unit circle. Oh wait, I want to make sure I did this part right, because I don't want to go crazy without knowing if I'm right at this point. First, before we even start solving, we need to make one thing clear. Do not cancel an x from both sides. Okay, well, I did that, so let me already erase my work. While this may seem like a natural thing to do, it will cause us to lose a solution here. So to solve this equation, we'll first get all the terms on one side of the equation, and then factor an x out of the equation. If we cancel an x from all terms, then it can be factored out. Doing this gives okay. Five x tan 8x minus 3x equals 0. X 5 tan 8x minus 3 like that. Or wait, I can just minus 3, yeah, like that. Equals 0. And we can get rid of it. Oh, x equals 0, okay. Because of that one rule, I forget. 5 tan 8x minus 3 equals 0. So now 5 tan 8x minus 3, or wait, I'm like writing this wrong. Add 3 over 5 tan 8x, divide by 5, tan 8x equals 3/5. Yeah, that's what they're at so far. Note that if we cancel the x, we would have missed the first solution. Now we solved an equation with a tangent in it in example 5 of the previous section, so we will not go into details of the solution here. Hence the solution to the trig equation. Okay. Can fit this all in one, watch this. So tan, inverse tan, 3/5 equals 8x. 8x equals 0.5404. Okay, so I have this now, so that's definitely in the first quadrant. All students take, this is positive, so all students take calculus. So it'd be like here. Oh, like this. So I'm going to take pi plus 0.5404. Equals 3.681 682 wait 6820 3.6820, then 0.5404. Now that I have both of these, we could say 8x equals 0.5404 plus 2 pi n, divide by 8. X equals 8x equals 3.6820 plus 2 pi n divided by 8. X equals, there, barely fit it, 0.5404 divided by 8. So 0.0676 plus pi n over 4. That's the first one. And then 3.6820 divided by 8. 0.4603 plus pi n over 4. Okay, let's see. 0.0676 plus pi n over 4. 0.4603 plus pi n over 4. Yeah, so it sucks. The only example that I couldn't understand was the last one, example 4. Like, so far out of all the sections, so. Yeah, I wish I understood that, but it happens, I guess. So I'll save this. Okay, what's the next section look like? Exponential functions. 2 examples. Wow, that's crazy. Next one has, oh man, 1.8 has a lot of examples. Only 3 examples, but like so many parts. Or I mean, I guess it's not too crazy because, see, 6 in this one, 5. Okay, so there's 14. This one has 9 examples. And the last has 15, so might be a little bit till I finish this review still, but hey, 4 more left to go, I think. Yeah, just these. And then I'm gonna move on to Professor Leonard's video on limits. And I'll go through these, see what I can do. All that. Let's see, after limits is derivatives, applications of derivatives, integrals, applications of integrals, and then extras. What's calculus 2 look like? Alright, cool. Alright, that's it.